implicit is like implied?
Implicit's like implied, yeah. So for implicit, think of implied. Explicit's like clear, clearly stated. Okay. So an explicit function would be something like y equals x squared plus 2. Okay? An implicit function would be something like this. X squared plus y equals, or negative x squared plus y equals 2. And the reason why it's implicit or implied is because we didn't solve for y all by itself. Okay? And why, in the implicit functions, they may not even be functions. Like, you could have something like this. X squared plus y squared equals 1. Is that a function? Is it? No. Why not? How?
Circle.
It's a circle. Does it pass the vertical line test? No. Now, you could draw this thing as two functions. You could draw this as y equals plus or minus the square root of 1 minus x squared. The plus side would be that, and then the minus side would be the bottom half of the circle. Okay? So you can, even though this is not a function, you could solve for it and make it two functions. The top part and the bottom part. Right?
So the only difference is explicit variables like on its own?
Yeah, explicit, you solve for y and you write it explicitly as a function of x.
Okay. Is it only y, or could it be like x equals y is second to the 2?
You could do x equals something, but then that's writing x as a function of y.
Okay.
This is writing y as a function.
So explicit is a function of y. So explicit is a function of y?
No, usually it's y as a function of x. But here is explicit z as a function of y.
That's explicit.
Because this is the independent variable, that's the dependent one. So the dependent one is z as a function of y.
Okay.
Does that make sense?
Yeah.
But we're solving for z, and the one you solve for is the one that like you're writing as the function. Okay? And so this is what we call an implicit function. That's an explicit function. Now what we're going to learn how to do is differentiate functions like this and that. So here is our good old friend, the derivative function, d dx. And what does he do when he sees an x? And he eats an x, what does he spit out? What's the derivative of x? 1. Which maybe we should think of as, like, he ate x, and he gave you dx over dx, and dx divided by dx is 1. Think of it that way. What happens when he eats x squared?
2x.
He spits out 2x times dx dx. But dx dx is just 1, so he gave you 2x. Okay? What happens when he sees a y?
dy dx.
He spits out dy dx. Right? You've been doing this the entire time. When you saw the equation, when you saw an explicit equation, y equals x squared, and I told you to feed it to dx, it gave you dy dx equals 2x. And then you probably didn't write it, but you could have written dx dx. Right? So every time that you've seen a y so far, you've written dy dx. Right? But you hadn't even thought about it, you just figured that's what we did. So the question here, well, let me say, what if I were to feed it a z? What would it spit out?
dz dx.
dz dx. Okay, so if I gave you some other function, z equals x to the fourth, and we fed that to d dx, what would he spit out?
dz over dx equals 4x to the third.
dz over dx is 4x to the third times dx which is just 1, so light and right. Okay, so now the question I want to ask is what happens if I feed, instead of y, what if I feed it y squared?
dy dx what?
2y
Times dx.
times dy dx. Okay? And why is that?
Because you're looking for the derivative of y.
Because you're looking for the derivative of y, like, what is y? You're assuming that it's a function of x. You're applying chain rule. Okay? So, it equals a y squared. It spits out 2y, which is like the derivative of the outside function. You're assuming y is like the outside function. So, derivative of the outside function would be 2y, and then you need to multiply by the derivative of the inside function, which is dy dx. Okay? What if it equals y cubed?
3y squared dy dx.
3y squared dy dx. Okay. What about z to the fourth?
Third dx.
4z to the third dz dx. Okay? So 4z to the third, you take the derivative of the outside function, which is z to the fourth, you get z, 4z to the third, and then you need to multiply by the derivative of the inside function, which is dz dx. Okay? So this is what the derivative function does to x's, y's, z's, y cubed, z to the fourth. Does that make sense? So now, what if I give you something like an expression? An expression is like part of an equation. So if I give you an expression like y cubed plus x squared, and I told you to feed that to d dx, what would you get?
3y plus 2x
3y what?
squared.
Times,
I don't know, I can't see the problem. 2x.
okay, what's missing?
Oh, dy dx.
Yeah, anytime you see a y, you gotta tack on dy dx, because of the chain rule. If you saw z to the fourth plus x cubed, and you put that to d dx, what would you get?
4z cubed dz dx. Plus 3x squared.
3x squared dx dx, which is just 1. Okay? Let's do one more. Y cubed plus y to the negative 2 plus x. You feed that to the derivative, what do you get?
Professor, so you have to put that after, like the dz dx, you have to put that every time?
Anytime you're differentiating with respect to a different variable,
Yeah.
because you're going to apply the chain rule. It's the derivative of the outside function, which is the 4z cubed, times the derivative of the inside function. The inside function there is z.
Yeah, I was asking if we could just write like 4z to the cube plus 3x squared.
No,
Okay.
you got to tack this on. That's the key, is you're using the chain rule, and you're treating z as a function of x, implicitly. Okay. So what about this one?
3y squared dy dx. Minus 2y to the negative 3 dy dx. Plus 1.
Okay. Okay, so what? what would we possibly use this for? Remember, Helen told us that this is the equation of a circle. And is y a function of x here? Does this pass the vertical line test? No, so this is not a function of x. It is a curve. It has a slope at every point on it. So how do we find out what that slope is? Like what if I wanted to know the slope right there? At like root 2 over 2 comma root 2 over 2, or negative root 2 over 2.
What's the differentiation of this equation and plugging it in?
Yeah, to find the slope here of this tangent line. What's the tangent line? Well, the derivative gives you the slope of the tangent line, but what is the tangent line?
Line that only touches 1 point on the curve.
Yeah, well, it's the line that touches the curve right there and has the same slope. In other words, it's like if you were to zoom in really, really close, take a microscope and zoom in on that point right there, it would look like a line, right? Like if you zoom in close enough, you don't see the curvy part, you just see a line. That would be the tangent line at that point. Okay? So, I want to know what the slope is here. I need to take the derivative and then plug in that point. So, I take this equation, I plug it into the derivative, and what do I get? What's the derivative of x squared?
2x,
What's the derivative of y squared?
2y,
2y,
dy dx,
dy dx. Derivative of 1, 0. Okay. So I haven't solved for the derivative yet, but I do have a derivative showing up. So what I want to do now is subtract 2x from both sides. And I get 2y dy dx equals negative 2x. And then I divide both sides by 2y. So that tells me that the derivative dy dx is equal to negative x over y, because I can cancel those two. So my slope at any point x comma y is negative x over y. Okay? So here are some points on this curve. This is the point 0, 1. What's the slope there? This is my x-coordinate, that's my y-coordinate. 0 over 1 is 0. So the slope is 0. Is that true? Is this horizontal there? Here's the point 0, negative 1. What's the slope? 0. Okay, here's the point 1, 0. What's the slope? Undefined, because it's going to be negative 1 over 0, which is undefined. That's good because the line is vertical there. Okay? The slope's undefined if the line is vertical. Same thing over here at negative 1, 0. My slope would be 1 over 0, which is undefined. And then any other point, like right there, that's the point root 2 over 2, comma root 2 over 2. You'll know that if you remember your trig. What's the slope? It's going to be dy dx is negative root 2 over 2 over negative root 2 over 2. I mean over root 2 over 2, sorry. Which is negative 1 over 1, which is negative 1. Which is good because that's about what the slope is negative 1 right there. Does that make sense? So this is going to allow you to find the slope of a curve even if it's not a function of x. Okay? Is that cool? Alright. I think it's pretty awesome. I think I'll talk about related rates in a little bit. Let's just get to work on some of these problems.